Example 5, find f prime, the derivative of f of x, if f of x is equal to 1 minus x over 2 plus x. So we're going to use, again, our definition that we have from the beginning of the section. So what we want to do is we want to find the limit as h is approaching 0. And so in our numerator, we're going to apply the input of x plus h. So we're going to have 1 minus x plus h divided by 2 plus x plus h minus f of x, which is 1 minus x over 2 plus x, divided by h. Okay, now when we look at this problem here, we have a fraction, two fractions in the numerator, so we have one term, another term, so we have two terms and one term in the denominator. So what we can do is we can multiply each term by the LCD. And so what do we know about the LCD? Well, the LCD is 2 plus x plus h times 2 plus x. So what we can do is we can multiply the numerator by 2 plus x plus h, since that is this denominator here. If we eliminate the parenthesis there, and then times 2 plus x, and then we're also going to multiply that by the denominator. Okay, so let's see what happens here once we multiply that. Well, when we multiply that out, what happens here is when we distribute it to both of these terms, okay, we can see that it's going to eliminate this denominator, and what's going to be left is the numerator. And the numerator we have is 1 minus x minus h if we distribute the minus sign. And then we eliminate the 2 plus x plus h, so we're going to multiply that by 2 plus x minus, and then in the next denominator we can then eliminate the 2 plus x. So we have 1 minus x times 2 plus x plus h. And then in the denominator, we have h times 2 plus x plus h times 2 plus x. Okay, so now we're going to multiply these two out. So when we multiply them out, we get 2 minus x minus 2h minus x squared minus xh. And then minus over here, we get 2 minus x plus h minus x squared minus xh divided by h times 2 plus x plus h times 2 plus x. Okay, now if you want to recall how to multiply these out, remember you can use the box method. So it's like 2 and then x if we look at the first one here. I'm not going to multiply it out, but just to give you here. So, and we know that we have 3 columns, 1 and then minus x and then minus h. So if we multiply that out, there's 2, negative 2x, negative 2h. This is x, negative x squared, and negative xh. Okay, now let's distribute the sign. So if we distribute the sign, then we end up with, on the left side, 2 minus x minus 2h minus x squared minus 8xh. And distribute the negative sign, so we get negative 2 plus x minus h plus x squared plus xh all over h times 2 plus x plus h times 2 plus x. Now I'm not multiplying that denominator out only because it's possible, since it's still in factored form, we want to see what we can combine and get in our numerator before we do anything. So let's see what we can combine here in our numerator. Well, we can eliminate the 2's, that's 2 and negative 2. We can eliminate the x, that's minus x and then plus x. We can eliminate the minus x squared and plus x squared. Minus xh and plus xh. So then what's left in our numerator? So we have the limit as h approaches 0. We can combine minus 2h and minus h, which gives us negative 3h divided by h times 2 plus x plus h times 2 plus x. Okay, so now we know that we can eliminate the h. So then what's left is the limit as h approaches 0 of negative 3 over 2 plus x plus h times 2 plus x. And now let's go ahead and evaluate the limit. So we have negative 3 over, we're going to let h be 0, so we have 2 plus x times 2 plus x, which is negative 3 over 2 plus x squared. So therefore, we can then say that f prime of x is equal to negative 3 over 2 plus x squared. And if you look here at this formula here, okay, what you can possibly do, instead of what we did over here, is you can combine the numerators first and then use the rules of dividing fractions. Whenever you're dealing with complex fractions, it's always, in algebra, you get to the point where it's a lot simpler to be able to multiply everything by the LCD as long as you can find the LCD. But here's another way of being able to solve.